Today we are going to continue with the problem which we have left in our previous class. So in the previous session, so we have seen the PRIMS algorithm. So how we are going to find the minimum spanning tree, right, using one of the method called as the PRIMS algorithm. So today we will take another example and we will try to see how we are going to solve or find the minimum spanning tree. Right, now let us consider the given graph G. So now this is the given graph. Now you can just note it, it is unconnected, it is a weighted graph, and totally how many vertices are there? 3, 4, 5, 6, right? So we have got totally 6 vertices. So now before solving the problem, now we try to make the columns. So first we are going to start with the tree vertex, then the remaining vertex, and the graph. As I had told in the previous class that after completion of every step you are supposed to draw the spanning tree, because each step contains marks in the examination. So, right, so after each step you have to construct the spanning tree. Let us start with the problem. So now you are supposed to find the minimum spanning tree. So we start with an arbitrary vertex. Right, so we are going to start with an arbitrary vertex A. So now initially we'll write bracket, both are empty, or we can say dash comma dash. So you are starting with this arbitrary node called as A. Right, so now you include A into your set of all vertices of your spanning tree. Now this set of all, so this first column, this is capital VT, that is the set of all vertices in your spanning tree. Now here this is our given graph. Now this is a graph G which consists of set of all vertices V and set of all edges E. Right. So this is our given graph for us. Now whereas this is set of all vertices in the tree. So first step you include A. Right. So you are having only one node called as A in your spanning tree. Now remaining vertices. Now what are the remaining vertices? Right, you start with B. You consider the vertex B. Now check from A, is there any edge or to B? Yes, we have an edge from A to B and the cost is 3. So you write down B bracket A comma 3. Right? Now this is completed. Now go to the next vertex, remaining vertex C. Now from A to C, is there any edge? You observe in your graph. So from A to C you don't have any edge, so we will write a dash comma and cost is infinity. Right? So we write dash comma infinity. So next we'll take the vertex D. So from A to D you don't have any direct edge, again for this also, so you are going to write it as dash comma infinity. So next we'll take edge E. So from A, because A is there in our spanning tree, see every time when you are solving, so you have to check with the vertex, one vertex should be in spanning tree and other vertex should be in the remaining set of vertices. Right, so that way you are going to do. So now you have A, from A the next vertex you have considered is E. From A to E, is there any edge? Yes. Now we have an edge from A to E with the cost of 6. So we'll write it as E bracket A comma 6. So next we'll take the last remaining vertex, that is F. Now check from A to F, is there any edge? Yes, we have an edge from A to F. So A to F there is an edge and cost is 5. So A comma 5. So now you have completed the first step. So first step what you have done? So now you included A in our set of all vertices, and for all the remaining vertices you found out which is the all the cost, whether A, this an edge is connected between A and that remaining edges. So now from these remaining vertices, so now you identify which is the minimum. So now you can see that B of A comma 3 is the minimum value. So now include this in your next step. So in your next step you will write, you will include in set of all vertices B of A comma 3. Right? So now what we have done, so from A to B you have connected. So initially it was empty. Now from A to B, so you have connected. So what we do in this step, so we from A to B, so you connect and include an edge from A to B with a cost of 3. right? So now set of all vertices in our spanning tree, how many vertices are there now? 2 vertices are there. One is A and the other one is B. Now go for remaining vertices. So now still remaining are C, D, E and F, right? So now you start with vertex C. Now from A to C, is there any edge? Look into your graph. So from A to C, you don't have any edge, right? So leave it. So then what about from B to C? So from B to C, yes, we have an edge from B to C and the cost is how much? 1. So we'll write, so in bracket you'll write B comma 1 because from B to C there is an edge with a cost of 1. Clear? So next, consider the next remaining vertex D. So now identify from A to D. From A to D, do you have any edge, direct edge? No. What about from B to D? From B to D also you don't have. So D bracket, what will write? Dash comma infinity. Because there is no edge either from A or B directly connecting to vertex D. Clear? So next, we will go to the another vertex E. Now here for this vertex E, now you are going to again do the same step. So you check from A. So from A to E there is an edge, right? So you have an edge from A to E. Now again consider B. From B to E, do you have any edge? Do you have any edge from B to E? You don't have direct edge. So only one edge is there, which is from A to E and cost is 6. So we'll write A comma 6. So next, lastly, we'll take the vertex F. And we'll see, do you have edge from A to F and B to F? So from A to F, you have an edge. Yes. What is the cost? 5. What about from B? From B to F also you have an edge and cost is 4. So now you should be very careful. Now what we have seen that from to this vertex F to this vertex F, there are two edges. From A also you have an edge coming to F and from B also you have an edge coming to F. But now you have to update now. You have to consider only that edge which is minimum. Which is minimum here? 4. Cost 4 is minimum. So we include the edge from B to F. So inside bracket we'll write B comma what is the cost? 4. Right? So now this is the cases where you should be very careful because now you can see that there are two edges. From both A also there is an edge to F. From B also there is an edge to F. In that cases you select that edge which is having the minimum cost. So once you have found this, now identify which is the minimum. So now you can say the cost 1 is very less. So now we consider this as our minimum and you include C into our spanning tree. So that is, now you have included vertex C. That is from B to C. So now what is that? From B to C you have drawn an edge. So this was the previous diagram. Right? From this was the previous diagram. In this diagram what has happened? Now A to B was already there. So A was already there in our spanning tree. Right? Vertex B was there in our spanning tree. In this step what we have done? So we have included C in our spanning tree. So we have included C. So we will mark or we will write this C in our spanning tree. So now how many vertices are there in our set of our spanning tree? 3 vertices A, B and C. Right? So now we will go to the next step. So we are here. So A, B, C are included. Now what are the still remaining vertices? So still we are left with the D, E and F. So we'll start with the D. We'll start with vertex D. Now from A, is there any edge to D? Check. From B, is there any edge to D? And C, is there any edge to D? Right? So from A, is there any edge to D? From A, there is no direct edge. What about from B? You don't have any direct edge. What about C? Yes, from C there is an edge to D and the cost is 6. So we'll write C comma 6. There is only one edge. Right? Now we'll go to the next vertex E. So now same process from A to E. Yes, you have an edge, right? So cost is 6. What about from B? From B to E you don't have any edge. And what about from C? From vertex C you don't have any edge. So only one edge you are having to E, that is coming from A and cost is 6. So we'll write A comma 6. Clear? So next go to the last remaining vertex F. So now this is the vertex. Now you check from A. So every time you have to compare, you have to see is there any edges from any vertex from spanning tree to the remaining vertices, right? So from A to F, yes, you have an edge, cost is 5. Now what about from B to F? Yes, from B to F also you have an edge, cost is 4. And what about C? Now from C to F also you have an edge, right? Now you see this case. Now this is another interesting case to work out. So now when we are looking about this vertex F, from A also you have an edge, from B also you have an edge, and from C also you have an edge to F, right? You check your graph. See, from A there is an edge, cost is 5. From B there is an edge, cost is 4, and C there is an edge, cost is 4. So now what we told, so PRIMS algorithm, how it works, now you have to select, you have to update that edge which has got minimum cost. Now here there are two values. So from B to F also cost is 4, from C to F also cost is 4. So now in this case what you have to do, now arbitrarily you can select any one edge and we will select this one, so from B, right? So B comma 4. So now which is minimum? We have cost as 6 and 4, so this will be the minimum. So in next step what we do, we include F into our set of spanning tree. So now what we have done, so in the previous thing, what are the edges, sorry, vertices was there in our spanning tree? We were having A, we were having B, we were having C, right? So edge from A to B and B to C and B to, right? So A to B and B to C. Now what you have done, now B to F. So you have added F also as one of the vertices in our spanning tree, and the edge which you have included is from B to F. So we will connect this B to F with the cost of 4. Right? So now how many vertices came in our spanning tree? 1, 2, 3, 4. So now still left over is D and E. So we will start with D. So now to node D, vertex D, now you check, is there from A any edge to D? No. What about from B? So from B you don't have any edge to D. What about from C? Yes, from C you have an edge and the cost is 6. And what about F? From F also you have an edge to D. So to D, to vertex D, two edges are there. One is from F and one other is from C. In this two, which is minimum, 5 is the minimum. So we will add F comma 2. Right? Sorry, not for D. So we are checking for D, right? So now for this vertex D, so edge from C you are getting and edge from F you are getting. So minimum is 5. So we will write F comma 5. So next last vertex E. So now to E, now you have to check from A. Yes, from A you have an edge to E. What about from B? From B you don't have any edge to E. What about from C also you don't have, and F you are having. So now for this vertex E there are two edges. From A there is an edge, from F there is an edge, and 6 and 2 are the cost, which is the lowest, 2 is the lowest. So we will add F comma 2. Yeah. So now, so one is 5 and another is 2. So we will consider this as the minimum. So now E, we add it into our spanning tree. So in the next step what we are doing, we are adding this vertex E. That is, we are including the from edge from F to E. So in the previous, what was the tree? So previous this was the tree. Now you are adding this. So in the next step, now this is how the spanning tree. So you see that every step by step the spanning tree is being created. That is what the greedy approach says. So when you are at this step, we found that this is the better one. Right? So now we included E into our spanning tree. Now almost all vertices are there in our spanning tree. So all vertices are there except D. So the last remaining vertex is D. So now you check, from A do you have an edge to D? No. From B you don't have. From C you are having one edge to D and cost is 6. And from F you are having cost is 5. And from vertex E also you have an edge to D, the cost is 8. So which is minimum? From F. So we will write F comma 5. So now you have only one node. So this itself is the minimum. So we will add this D into our spanning tree. So in the last step, now D is also added. So D is also added. So that is edge from F to D. So these are the previously this was our tree. So now A from B to C there was an edge, and we connected from A to B and B to F and F to E. So this is your final spanning tree. So next, if you see here, you don't have any edges, so it is empty. So now the remaining vertices are empty. So we stop our algorithm, and this is your spanning tree. This is the minimum spanning tree. Now you count all the costs. So find the total cost of all these things here. 3 plus 4 plus 1, which are the edges you are connecting, right? Now you find the total. So this that is this total. So 3 plus 1 4 plus 4 8, right? Plus 2 10 and 15. So that will be your minimum cost of our spanning tree. So now this was another example. Now what we have seen, now how we are going to try to solve the spanning tree, or by using PRIMS algorithm. Now how we are going to solve the spanning tree. So you have to solve. So right now we have solved 2 examples. Similarly, work out these 2 examples and try to solve more examples, right? So now we will try to look into the analysis of this particular what is that PRIMS algorithm.